This is far from a small event, and today's theme is simple. Since 2020, Zimbabwe has been building, and here is the proof. This is an online public forum for students, lecturers, researchers, public sector leaders, diaspora builders, partners, and the global quantum community. A few quick notes before we begin. The session is being recorded for community education and possible publication on the AQC YouTube and related channels. Please keep that in mind when speaking or posting in the chat. Use the chat actively. Tell us where you're joining from, share your questions, introduce yourself, share your LinkedIn profile, and our team will collect questions for the panel during the program. So there'll be no need to stop. Just post your questions the moment you have one in the chat, and our community moderator will make sure that we have those questions put out to the panel. And today is most importantly about access, proof, and next steps. We want every person here to leave knowing what quantum computing is, why it matters, and who is already in the building and how to get involved. So let's begin. To open the Zimbabwe-side convening frame, I invite Lorraine Majiri to say a few words on why this gathering matters for Zimbabwean learners and institutions. Lorraine is a master's student at UDS in Canada from Kariba, graduated with her first degree from CUT. She is also the national coordinator for Zimbabwe at the Africa Quantum Consortium. Lorraine, the floor is yours.
Thank you very much, Aura, for the warm welcome. It's an honor to be here, and I'm grateful to see so many people joining. And on behalf of QZimbabwe, we are happy to welcome you all to this very important event today. And we are hoping to all ask the question that is always on people's minds when we talk about quantum, which is in line with, how, what's the path and how can we get this? So today we are honored to have you here to discuss those paths. So thank you.
Thank you, Lorraine. I would like to give the floor now to our opening guest speaker. Our opening guest speaker is Dr. Guilford Tapera Hapanyengwi, Director of ICT at the Zimbabwe Council for Higher Education, and his work sits at the intersection of digital transformation, technology services, and quality assurance across Zimbabwe's higher education sector. He brings the public sector view on why emerging technologies matter for institutional readiness, innovation, safety, and national competitiveness. His role today is to frame the national question: why should Zimbabwe care about quantum and emerging technologies now? We are asking him to set the foundation: skills, institutions, readiness, and the importance of preparing early. Dr. Hapanyengwi, welcome. The floor is yours.
Thank you very much, Aura, for that stellar presentation of who you said I am. I'm not sure I recognize myself from what you have just said, but that's fine. I'm with the Zimbabwe Council for Higher Education, as indicated, and I'm the director of ICT. Maybe very briefly, the Zimbabwe Council for Higher Education is the regulatory body for higher education, which means for universities in the country. What we basically just do is try to ensure that there is quality in the institutions, there is quality in the way the institutions deliver education, and there is quality in the graduates who come out of all those institutions. So in a very twisted way, we set the pace, but also we accept the pace which is set, so that we ensure that there is quality in whatever pace which is actually set. Definitely, the issue of quantum computing, there is no question that it's not only trending, but it's actually something which is very necessary to be inculcated in our institutions in proper manner, if I could actually put it that way. Why am I actually saying that? You find that even if I was to diverse a bit and go, let's say, to even things like, let's say, artificial intelligence, and see how they have actually been included in the Zimbabwean education sector. There is a bit of, at times, lethargy when new technologies actually come in the speed with which they can actually be assimilated. Part of it is because of our situation, where we are situated, if I could actually put it that way, within the whole global perspective, so to speak. But the moment we embrace it, then we embrace it with gusto, and we embrace it in a way which we believe will actually go ahead and make a difference. When I met, I don't remember whom I met. Was it Lorraine, whom I actually met at some forum last year? That's when we really spoke quite a bit about how we can quote unquote fast track the involvement of quantum computing within the Zimbabwean education sector. And I think it is the responsibility of this forum, as informal, quote unquote informal as it is, to really find a way of ensuring that we embrace quantum computing, and we ensure that it's really embedded into the whole of the educational sector within Zimbabwe. As you might actually be aware or might not be aware, the Zimbabwe has embraced what is called a heritage-based education 5.0, where we are focusing over the last few years, where we have actually been focusing on the 5 pillars, where we're talking of teaching and learning, and then we're also talking in terms of research, we're talking in terms of community service, then there is the innovation and industrialization aspect. So whatever we are actually looking at, we are really looking at our education making a difference within the country. So anything which actually goes ahead and makes a difference, not only in the education sector, but in industry and in the general day-to-day lives of people within the country. That's what we are actually looking at. And definitely, quantum computing is actually it's cutting edge, where it is actually going to really make a very, very big difference if Zimbabwe is really very serious about the issue of science and technology, and actually then moving into the future. So basically, I think with this, we are basically saying, I don't know what this amoeba is actually is going to actually take shape like, in as far as influencing the whole sector. But I'm saying anything actually goes in as far as whether it is something which is pointedly coming through Zimbabwe Open University, who are part of our work today, or whether it is actually coming from outside looking in. For sure, what we're actually saying is we want to be able to utilize all the resources, some of which I'm actually seeing today. I thank you.
Thank you so much, Dr. Habanyengwi. I have a question for you, a quick follow-up question to what you've shared. And I'm hoping that maybe you can give us some clarity on what kind of talent, from your own perspective and your experience, what kind of talent and institutional readiness does Zimbabwe need, do you think, to take a conversation like this forward? You've mentioned our curriculum. You've mentioned we've now on our heritage-based education 5.0, and a big part of, I think, where all of this falls under would be under innovation and industrialization. But what do you think is actually needed for talent and institutions to be ready for this?
What is needed, the moment we make it a bit more structured in the sense of whether it is actually coming in included in courses, or actually included in degree programs, then that way it's actually mainstreamed. Because the moment it's actually then brought in as, let's say, part of let's say curriculum in physics, or let's say as part of curriculum in engineering, the moment it's actually brought in like that, then the way we act or the way we behave, as not only Zimbabwe Council for Higher Education, but all Council for Higher Education, so to speak, the way we do it is, the moment a new thing is brought into the curriculum, we always take external experts to come and say, is this the best way of actually bringing it into the curriculum? And then so we'll actually then be guided in terms of the curriculum which is required, the laboratories which are required, the human resources which is required, the whole ecosystem which is actually required for that. So there isn't really, that's why I was actually saying the beast, we don't know which part of the beast is actually going to start being alive more than anything. But that's why I'm actually excited that we have Zimbabwe Open University here and other universities which are already actually showing interest in this whole thing, because it is through that channel that things can actually go ahead and happen.
Thank you so much for that submission. And I agree with you. And you've said something that I'm not sure whether you have realized how you have actually framed this conversation going forward. But what you have described is not looking at quantum as a standalone thing. Like, okay, we're going to have a quantum course. You've framed it in such a way that quantum becomes integrated with what's already existing, integrated into engineering, integrated, just showing the real use case of quantum in an almost applicable, practical format rather than just as a pure science. And I think that's a really interesting approach to introducing something like that into our higher education system, and probably even lower down, going right down to primary school, because the truth is, this isn't just for adults. It isn't just for our our tertiary students. It should be something, a conversation that started right from primary. But we'll stick to tertiary today because I'm biased because I have such a passion for the young ones. But hopefully our young leaders in the room today can see the opportunity ahead of them. So thank you so much for sharing your thoughts and your expertise, Dr. Hapanyengwe.
In fact, Ora, the issue we are talking about, to say at what level should things start, is very, very significant. And when we are talking in terms of universities, fortunately for us, we're not talking in terms of universities in Zimbabwe. They have got the ability of then affecting what happens at teachers' colleges and what happens at secondary and primary school. So there isn't really any cut formula in how we should actually go ahead and introduce. But the more the ideas, actually, the better. Because as far as I'm concerned, if we want it to be to really be ingrained, then the lower it starts, the better it actually becomes. Thank you.
Thank you so much. That is very true. And I will drop a seed. And throughout this conference, this forum, I'm going to be dropping seeds of thought. And it reminded me, this conversation reminded me of, there's a school in Louisiana, in New Orleans specifically, called Rooted School. And they have done something quite unconventional where it's a high school that has been integrated into a university campus. So for example, if you imagine at UZ or at Zimbabwe Open University, and there's an entire block that's actually high school students, and they're doing high school subjects, but they're being introduced into, like, it's a hard fast track into tertiary education. And so they can sit in on certain lectures, they can start to kind of get their gears going. And I think a model like that would probably be quite successful as well. So that's just a seed I'd like to plant before we move on. So let's move on from this conversation. And rather, let me say, let's evolve. Let's evolve the conversation. So Dr. Hapanyengwe has set the tone. Our keynote speaker is Professor Murad Telmini, and he's joining us from Tunis in Tunisia. He is a professor of physics at the University of Tunis, El Manar, director of the research laboratory at Atomic and Molecular Spectroscopy and Applications. Yes, I hope I got that right. And the coordinator of the Tunisian Quantum Network. He's the president of Tunisian Metrology Association and an advisor to the Africa Quantum Consortium. He's been a strong supporter of the quantum community building across Africa. And today he will give us a clear foundation in quantum computing. What is this mysterious quantum computing? What makes it different? What is possible now? And why does learning it matter? And the goal here is to not overwhelm anyone, but the goal is to give us enough of a foundation to understand why this field matters and how beginners can start. So Professor Telmini, thank you so much for sharing your expertise with us. And we cannot wait to learn from you. The floor is yours. You're most welcome.
Thank you very much, Ora, for this introduction. I'm very happy to be part of this very nice event. I congratulate colleagues from Zimbabwe for initiating this event. So my thanks go to Zimbabwe Open University, of course, but also to the African Quantum Consortium and the efforts led by Farai for years and years now. We knew each other for like 6 or 7 years now, Farai. Yeah, so I'm very happy really to participate, and I'm sending greetings from Tunis together with Sarah, who is also in the audience. Okay, so let me share my presentation of today. Okay, so
yeah, thank you, Professor Taumini. It's been a long time. Yes, years. I think ever since 2019, and that's a long time for sure. And it's a pleasure to have carried this field this far with your support, and looking forward to what we build from here as well as we go. Thank you. I think your slides are on screen, and I'm going to draw back. Thank you.
Thanks again. Are you seeing my slide?
Yes, we can see your slide.
Yes.
Okay, fine. So as requested by the organizers, I will try to be very, very short and just speak a little bit about the foundations of quantum computing, introducing quantum computing for people who doesn't have maybe too much information about it. So the outline of my presentation will be very simple. I'm just following the questions asked by the organizers. What the quantum computing is, how it differs from classical computing, what is real today and what is still developing. More important is why African students and institutions should learn now, and to finish with maybe some advices or some a practical way for beginners to start in this field. But before going through that, let me start with maybe some news. I like always start with the latest news in the field. And what I learned last week is it's important news from Chinese colleagues who succeeded to build up a atom quantum computer with 2 cores. So now we are speaking about the possibility to have not only 1 core quantum computers, but multi-core quantum computers, which opens the door for even more impressive applications. This breakthrough follows another one a few months ago, as announced by Google team. It is not the first time they announced this kind of quantum advantage, but this time it seems very, very serious, and almost no contest about that. So what is the announcement about? It's about what we call quantum advantage. And the quantum advantage is simply the possibility that the quantum computer can realize or implement some or achieve some computation in a reasonable amount of time, say seconds, minutes, or even hours, while the most powerful computer in the world cannot handle that task, even if we let it run for years or thousands of years or millions of years. So in this case of this announcement with the Willow chip, quantum chip, as you can see, remember to see the 13,000. So this device was able to perform some computation task 13,000 times faster than any supercomputer available today. So this is really impressive and opens the way for fantastic applications we are all waiting for. Of course, I think everyone is aware that the Nobel Prize last year was awarded to these 3 scientists from USA for their work in the field of quantum, and more specifically for the discovery of macroscopic quantum mechanical tunneling, an electric circuit, which is on which is the basis for the superconducting quantum circuits and the superconducting quantum computers. Used, for instance, by Google for the achievement I just told about. So quantum is in the news almost every day or every week now, and this way we are waiting for after the AI is coming, and it's good to be aware of these developments. So now back to the outline of the presentation, starting with what quantum computing is. So all of us knows what computing is and how to use like a calculator or a computer just to make simple calculations. For that we use the binary digits called bits, and we gather them into registers like the bytes with 8 bits. Each one can have only can only probably 0 or 1, so it's binary. And with simple operations, you can make like an addition with the sum and the carry, and that's how you can use your calculator to add some numbers like the example here. So this is very well known and very easy to know. So for that, we need at more fundamental level to build up a half adder, just a very simple device with XOR and gates with 2 bits as input. Each one can be 0 or 1. And at the output, you have a sum and the carry. I think everyone had that lecture undergraduate at the university in computer science or physics or mathematics. And the rules are very simple and summarized in this table of truth. 0 plus 0 gives sum 0 and carry 1, and so on and so forth. The idea is that using quantum properties and quantum bits and the quantum gates, we are able to do the same task using this quantum thing, where the bits are replaced by qubits, and instead of having the classical gates, we have something called quantum gates, make some measurement, and be able to do the same task. So you see here this graphic showing schematically what is a half adder, what does a half adder looks like in quantum. It may seem complicated if you see it for the first time, but let's say that at the left side you have the input, and at the right side you have the output. You make some manipulation and end up with some measurement, and at the end of the day you can just implement the same operations to sum 2 bits and have a sum and a carry. Well, of course, you can say, and you are right if you say that, do we really need a quantum computer to add 2 numbers? Of course, no, but this is just to explain how things work. In the simplest case, you can easily imagine much more complicated circuits which are able to perform much more complex calculations. Well, so how the quantum computing differs from classical computing? I started explaining that by saying that basically we replace classical bits by quantum bits, we call them qubits, replace the classical gates like OR, XOR, AND, etc. by quantum equivalents, quantum gates, and at some point make some measurements, so use the rules of quantum mechanics, superposition, entanglement, and interference to convert the quantum information into classical data that can be processed later on by us as an output of the calculation. So for the bits, as I said, it's a physical system that can have 2 values, 0 or 1. A qubit is much more complicated. So actually it's a quantum system, and in the quantum mechanics, a system that have, let's say, 2, we speak about quantum levels. not there 0 and 1, can be in states 0 or 1, exactly like a bit, but can also be in any superposition of 0 and 1. And this is how the magic of quantum starts, because with all these possibilities, you can explore a much larger ensemble of possibilities, a space of configurations. So you can do much more complex calculations. So of course you will not, so to make it easier to see, here we use the Bloch sphere. It can seem a bit technical, but the idea is very simple. Let's say instead of having only two values in the classical case, which are the poles here of this sphere, it's like the planet Earth. So North Pole for 0 and South Pole for 1. With quantum, we can explore the whole globe, and every point of the sphere represents a quantum state that can be manipulated, and so open the possibility to explore much more complex problems. So of course, like in classical computing, you do not manipulate the bits one by one, but you use registers like the byte. So here, for the example of 6 bits to have a register, the classical register, as I said, you can only have 0 or 1 for each bit at the same time. While if you use the quantum register, since each qubit can have all these additional possibilities, you can imagine how large is the space of configuration or the possibilities you can reach with the quantum register. So you have a kind of intrinsic parallel calculation thanks to the properties of quantum mechanics. So now you have your qubits, you need to make operations on them. But before that, let me just mention that this is not only theory, you have also the experimental implementation of the qubits. So many technologies already exist and are available, with some advantages and drawbacks for all of them. But they are working quite well. So you have the superconducting qubits, the NMR at room temperature, the trapped ions, the quantum dots, the nitrogen vacancies in diamond. You have also full optic systems, neutral atoms using laser cooling, and so on and so forth. So just to let you know that the implementation is already done for building the qubits. So now you have your qubits, your registers, you need some operations on them. So you need the equivalent of the logic gates. All of you know them very well, the AND, the NOR, etc. And in quantum computing, they are replaced by the quantum gates. So some of the gates operate on a single qubit, the first line, or in 2 or more qubits, the second line. I'm not going, of course, into the details here, but the idea is that we can initialize a quantum register, the quantum bits, operate on the state of this register using these quantum gates, produce some quantum state, make a measurement, and then end up with a solution to the problem you are looking for. This is the main idea. So now if we look back to the half adder, I hope it's a little bit more clear now. At the left side, you have the qubits, Q0, Q1, Q2, Q3. Q0 and Q1 are for the input, for the half adder. And Q2 and Q3 are here for the result, for the output of the computation, means the sum and the carry. So you initialize them in some state and then operate some gates, make a measurement. The symbol here, the black symbol at the right side, is measurement, and then register make a record of the measurement on the classical register, and be able to make the calculation. So why does it work? At least even in this very simple case, it works very well thanks to a couple of main properties in quantum mechanics and the quantum world: the quantum superposition and the quantum entanglement. These are the two key words: quantum superposition and the quantum entanglement. So let me, in the following couple of slides, try to explain them very briefly, saying in the meantime that all this was possible thanks to all these people, these bright and brilliant scientists who invented the quantum mechanics about a century ago. So it's always a good opportunity to pay tribute to them. So regarding superposition, the idea is that a quantum system, let's say an atom in an atomic, in a magnetic field, or a superconductor, or any other, or a quantum system, actually can be in a superposition of states. This idea is not very intuitive. It's even counterintuitive because at our scale, objects doesn't behave following any superposition. But just to give you an idea what it is about, if you can look at this graphic, and you try to guess the number of cubes you can see. It's a kind of optical illusion, but just to popularize the concept of superposition. So if I give you a few seconds to guess the right answer, you can see either 6 cubes if you consider the white face as the upper face of cubes, or alternatively you can see 10 cubes if you consider the white face as the bottom face of the cubes. So the idea here is, even in this simple case, you do not have a unique answer, but you have 2 possible answers, namely 6 or 10 cubes. And before focusing your eyes and discriminating between both, the answer can be like a kind of superposition between both. So this is the idea. Of course, it is not quantum at all, but the idea is that in the quantum systems can have 2 or more possible states, and they can be in one of them or even in a superposition of them. And when you make the measurement, you fix the state of the system, and the result is only one of among these possibilities. So this is for superposition very briefly. It works extremely well in the microscopic world. Extrapolating it to our scale gives kind of funny or like weird situations, like the Schrödinger cat, which can be to some extent in a superposition of alive or dead. Of course, this is part of historical discussions at the beginning of the development of quantum mechanics. Today we understand very well that it is not relevant at all for cats or for any other macroscopic objects because of decoherence and so on. So the idea is that these concepts work very well where they are relevant, which means mainly in the microscopic world, with some exceptions to the mesoscopic scale and even bigger for very specific systems, but not in our daily life. The second concept is entanglement. This is probably the most critical and the most hard to explain. So let me just to introduce it very as simply as possible. If you take 2 quantum systems, number 1 and number 2, each one of them can be in one of 2 states or superposition, here in red or blue. So if you make them interact at some point and then separate and prepare them in a specific state and then separate them by an arbitrary distance, they can be very, very far away one from each other, and you make a measurement on one of the states, what the experiment says is and proves is that the measurements are correlated. It's like the 2 particles are still interacting or correlated or entangled, this is the word, even though they are very, very far away. And this also opens the door to possibilities for computing, which are absolutely huge. So two key points, superposition and entanglement. Using these, what is real today? What can we do with these quantum properties, and what is still developing? So for what is already available, and actually is available for a long time now, for decades, is all the electronics, so the transistors, also the time and frequency standards like the atomic clocks, the lasers, things we are using in everyday life, laptop computers, MRI in the hospital, smartphones, GPS for the positioning. All these technologies are using quantum properties except for entanglement. Entanglement is very specific. So this is, we have already enhanced. This allowed, for instance, speaking about computing, the possibility to build up extremely powerful devices and computers like the IBM Summit with an impressive number of operations per second. And you have even now today even more powerful computers like El Capitan, which is even more powerful. With the, it was also possible, thanks to these properties, quantum properties, to make the devices for storing smaller and smaller. Have a look here at the just a 5 megabyte hard disk. You see this, the scale here of this huge box. 5 megabytes is less than the size of my PDF presentation of today. While now you can store infinitely, not infinitely, but much larger amount of data on very small devices. So this was possible because technology allowed for making devices smaller and smaller. And you can see on this chart, starting in the early 70s to about or around today, that what you can see here, the numbers on the top of the histogram are the size of like a single device, a transistor, in nanometers. So you see that we reach today the scale of 1 nanometer, and it is not possible to go below this value because you reach the atomic level. So all this is already possible today on the classical side. What about quantum? Why we are speaking about quantum? Actually, quantum started more like a threat, like 20 or 30 years ago, because it has been proven that if we use the quantum properties, and if we are able to build up a perfect or very nice quantum computer, we are able to crack the codes or the encryption used for cybersecurity and all the transactions and finance and defense, etc. And to give you just an example here, a couple of years ago, a group of Chinese researchers has proven, here you have the paper in Chinese Journal of Computers. I'm not sure if everyone can read the Chinese. I can't read Chinese, but you have, hopefully you have the title here in English. So using the quantum annealing to show basically that it is possible to break the most powerful code used in cyber security today. So indeed, most of the transactions, including secured communications, trade, electronic commerce, telecommunication, etc., are based on some protocols that prevent any spy to steal the information. So for that, very large numbers are used, like the one you have here, the RSA 2084 and the 48, excuse me. And just in a couple of words, the main idea is that this number is the product of two prime numbers. And to be able to crack the code, you need to find these prime numbers. And it's extremely hard, the problem, and which is not possible to solve with the supercomputers, the classical supercomputers. It will take billions of years. So what was like the breakthrough and the big news in the 90s is that Peter Shor has shown theoretically that if it is possible to build a quantum computer, these numbers, these prime factors, can be found very easily within seconds or minutes, and you can imagine all the threats it can cause for the security of the whole economy, defense, etc. So at the beginning, quantum computing could be seen like a threat, which was at the origin of international race to build up the first quantum computer. So some devices already exist. They are not perfect, but they already exist for education or even for some computation. But they are still at what you call the noisy intermediate scale quantum, NISQ, which means that these computers are able to perform some tasks, but are far from being universal and perfect. Okay, so this is the main idea to know where we are now. At the same time, the developments are very, very fast, and you have companies like D-Wave, like IBM, which have announced for a long time now roadmaps, and they're sticking to the roadmaps and developing every year bigger, larger quantum circuits with more and more qubits, like 1,000+ qubits now for IBM, and we expect that within a few years we can have the first devices that can really make the breakthrough. To go faster in the presentation and argue about the involvement of African students and institutions, now there are many reasons. First of all, everyone in the world, every country is, most of the countries, all the developed countries are running, are part of this race. So you can see this recent chart with huge numbers here in dozens of billions of US dollars. In Africa, South Africa started already, other countries are coming. So this is one reason it's crucial, it's strategic. On the academic side, you can see in this chart from the colleagues from American Physical Society at the bottom of the slide, the right side, the increase here, the relative increase of the number of researchers in different fields of physics, and you can see that quantum information is increasing. So there is a trend, and we should be involved. This trend is confirmed in this chart, or this map shows the more or less the number of scientific papers downloaded in the quantum information and quantum computing field within different countries. And hopefully, as you can see, we are not in Africa completely absent. So we are there, but we can do better. Another very important reason for us, for our young students to get involved in quantum computing, is to participate to solving our challenges as Africans, climate change, water management, agriculture, food. And here just I wanted to show one case regarding health and the drug discovery. So to test a new molecule, it's very hard using the present computers, because the time you need for the calculation to characterize the properties of this molecule for a drug increases exponentially using the classical computers, while this time can go only linearly using quantum computers. So to give you just a flavor of that, in the case of penicillin, very famous molecule, to study all its properties from chemical point and physical point of view, using the most powerful classical computers now, it's impossible. While with less than 300 qubits, the hope is that it should be possible, and it opens the door for new drugs. For you can imagine all the other possibilities. So for that, what we need at first is to introduce quantum computing and the quantum technologies in general within the curricula. We did it in Tunisia. Other countries also did that, even before us in South Africa, Egypt, Morocco. So introducing the quantum information and quantum computing and related quantum technologies in the at least at the master degrees. So this seems to me very important. To end with the very last question, so what would be a practical beginner pathway? So here I'm addressing mostly the young fellows from Zimbabwe and other African countries. So you can start by just very easily relying on yourself and get free training and tutorials from already available free platforms like IBM Qiskit, Xanadu, Penny, etc. I encourage you to get involved in the African networks like the African Quantum Consortium, African Quantum Alliance, the national branches of Q World, etc., and register in any African training school and workshop you can find online, like the African School of Physics, etc. So in any case, you can also contact easily all the senior people you can find in the networks or in this kind of events and ask for advice, and we will be very keen to help you embark in this field. Thank you very much.
Thank you so much, Professor Telmini. That was an incredible technical ground and kind of set the tone in terms of understanding what is quantum computing, how it is actually real, but still developing and already important enough for serious learning. But I would like to challenge you, and I know we're over time, but I'd like to challenge you, Professor, with a question. So a lot of we have quite a few people within our audience who have no technical background whatsoever. And I know we're probably sitting there and looking at the zeros and the algorithms and looking at the circuits, and they're like, am I in the right room? Why am I here? What? I don't understand. So if you could come up with an analogy, I have a suggested analogy, but I'd like to hear yours first. An analogy that describes what quantum actually is for someone who has absolutely no technical background whatsoever. How would you describe it to them?
Well, this is not an easy question, because one of the problems with the quantum is that it is counterintuitive. So because the matter at the microscopic scale obeys to laws which are completely different from the physical laws we are used to, like the Newton mechanics and all this stuff. So maybe the key point is just to admit that the physics governing the matter at the small scale is different from the one around us at our level. So this is a starting point. And then, of course, you need to go through a minimum of mathematical background like linear algebra, and then little by little being used to quantum concepts. And at some point, it becomes very natural and you will feel very comfortable with it.
Thank you so much. Thank you so much for sharing that. And I guess a question that we'll be answering throughout the course of this forum will be, why does it matter? Because I think that question continues to persist. Like, what does it mean for me every day? The same way 5 years ago, AI, it was just about algorithms. When we spoke about AI, it was very complicated up until people started using Claude or ChatGPT, and suddenly AI became real and tangible. And I think that's what we're that's what we're looking to create. Like, how do you humanize quantum as well, so that people understand the reason why it's important, why a student needs to go and convince their parents, I need to study quantum. And I hope that this forum has the answers that you're looking for if you're in the audience and you're asking this question. But I think we've laid a fantastic foundation. Thank you so much, Professor Telmini, for sharing your expertise. It was deeply appreciated.
Thank you.
Now we move on to Africa's wider quantum picture and onto our featured speaker, who is Dorcas Atuwa Ado. joining us from Ghana. She is a lecturer in the Department of Mathematics Education at the University of Education in Winneba, with research interests in quantum algorithms for material science. She is president of One Quantum Ghana, serves on the coordination team of the Africa Quantum Consortium, and was recognized among the International Year of Quantum Science and Technology's Quantum 100 for her work advancing quantum education, literacy, and diversity in Ghana and beyond. Today, she will help us understand the state of quantum in Africa and what is already happening, where the gaps remain, and how Zimbabwean students, lecturers, and institutions can plug into the wider continental movement. Dorcas, welcome. I'm so honored to introduce you. You are still muted if you're speaking, Dorcas.
Yeah.
Wow.
Okay. All right. Thank you, Yara. And thank you so much to the team. And I really appreciate everyone's efforts and for inviting me as well. So I'll be speaking on, I don't know if you can see my slide.
Yes, Dr.
Yes, we can.
All right, please. Okay, thank you. So today I'll be speaking on the theme quantum computing in Africa, where we are, where we are going. And I mean, the topic is so timely because quantum computing is no longer a futuristic idea. Around the world, governments, institutions, industries, and everyone is investing in quantum uh, science and technology. And the question for us is not whether quantum science and technology will shape the future, but rather what role will Africa play in that future for us today. So we may want to reflect on these two things. First, where Africa currently stands in the quantum ecosystem. And secondly, what practical steps we must take to move from participation to leadership as well. So I look at this. So if you see this image, it actually represents the heart of my presentation. On one side, so we have different groups of people. On one side, we see people learning, others are experimenting, others are coding, and others are collaborating as well. And this actually represents on the left hand side, if you look at it, it actually represents where we are now, a continent with growing curiosity, emerging talents, increasing interest in the quantum science and technology space. On the other side, if you look at on your right, you realize that you see a very well advanced technology, connected, empowered for Africa. And this represents where we are going in Africa. So my right is representing where we are going in Africa. That is not simply consuming quantum technologies developed elsewhere, but we would all want to contribute to quantum research, quantum education, algorithms, communication, and anything you might be thinking about. And the pathway, so you have others going through the pathway, which is very important to us because it reminds us that Africa's quantum future will not happen automatically. It requires a deliberate investment in education, infrastructure, collaboration, policy, mentorship, community building, and among others as well. It's also reminds us that quantum computing is not only about machines, it's about the people, it's about the students who are here. It's about researchers who are here. It's about educators, policymakers, innovators, and the community you and I belong to. In the global context, you realize that globally, every country, every nation has become a strategic priority globally. Countries are investing heavily in terms of this quantum we are discussing today. People are talking about quantum startups. People are looking at the applications in different areas. And this global race is not only scientific, it is also economic as well. It's about technology, it's about the geopolitical space that they actually belongs to. And these nations are asking how quantum technologies can actually strengthen their cyber security in terms of drug discovery, in terms of finance as well. And for Africa, the message is simple: we must participate early, not to adapt late as well. And in many previous technology revolutions, we noticed that most times Africa was just left behind. I mean, we only consumed what happened. So there was the era of data science, machine learning, a lot of, I mean, technology has come to pass. But then what happened with Africa? What happened with the data from Africa that we could actually use on our own? And we just became consumers. But then the good news for us this time with quantum science and technology is that it is evolving, it is growing. So Africa has a room to actually partake and play a role in all this. So the challenge is not only to catch up, but to also position Africa as a meaningful contributor. But where exactly is Africa now in the emerging quantum landscape? We are still developing, but there are encouraging signs as well, because I mean, when you look at South Africa, there are lots of innovations, there are lots of research, and a lot of education there. And South Africa has been one of the most visible countries in terms of quantum research, especially in quantum communication, quantum optics, and others as well. Then we have Algeria, we have Egypt, I mean, who are also part of Northern Africa, who are also growing, advancing, Morocco, introducing courses into their curriculum to promote quantum science and technology. And we have, when you come to West Africa, like Ghana, I mean, it is just starting for us because we are now doing the education and all that. One important factor is access to cloud-based platforms for us. So even where we do not yet have physical quantum computers, students and researchers can actually begin to learn through the platforms that was earlier mentioned by the speaker. This means that Africa's entry point does not have to wait for expensive hardware. Africa does not need to have hardware before we could do something. The cloud base is available for us to actually work. So we can begin with education like we are doing today. We can begin with software, algorithm, simulations, and other activities as well. So to understand our potential, we must look not only at what is missing, but at what we already have. And we have so much. We have strength in diversity. And with strength in diversity, I'm looking at the young talents we have today, the young talents that are showing up for Zimbabwe, they are showing up for Ghana and any other country. And Africa has a large youthful population, and many people are eager to engage with this new technology in this digital era we are talking about. So if we introduce our quantum concept earlier and in acceptable ways, we can build a very strong future workforce as well. We have a very strong community as well. student groups, the AQC, the QWorld, the different chapters. I mean, everyone is making an effort to actually introduce quantum computing, to collaborate, and to work together as well. And the good news also is that now universities are embracing STEM education. In embracing STEM education, they are also opening the education curriculum to data science, to computational science, to physics, engineering, and mathematics. And these are the foundation for quantum computing. So then Africa's strength is not only in resources, it is in its people. And the people are here today. The people are representing us today. It is in our diversity, the creativity, and our willingness to learn as well. However, while this strength, we acknowledge that this strength are there are also challenges that come our way as well in terms of infrastructure, in terms of curriculum, in terms of funding, and other things. So, I mean, when you take the curriculum, I mean, like, if I take it from the third point, if you look at our curriculum now, many universities and schools do not actually have a quantum-based courses. I think just a few. For us, even in Ghana here, most people are exposed to quantum at the tertiary level only when they are either reading physics or they are doing mathematics. I mean, doing math and being exposed to quantum or chemistry is not compared to physics. So if if you are doing any other course, computer science, you might not have this opportunity to be exposed earlier to do this. But then they often encounter quantum computing as a structured subjects which they are not used to. It's a constraint. So we might have to, Africa might have to look at in this digital era where technologies, emerging technologies are evolving, how do we incorporate all these technologies into our curriculum, not just with quantum alone, but then with AI, machine learning, and the others as well. Then another constraint for us as Africans is the funding aspect. I mean, it's heavily requires lots of support, financial support in terms of training. If we were to have this program as a physical one, we're going to need funds to actually run this program. So sometimes, because of limited funds, I mean, we decide to go online to do some of these activities and all that. So training, workshop, in terms of postgraduate research as well, because for postgraduate research, this is where novelty comes in, especially for PhD students. This is where publications are counted and all that. But then most African countries do not have the funds to even support their postgraduate students to actually do research. So you have a limited number of people actually going in even to a higher level PhD in this physical science areas as well. So it's very important that we look at the funding as well. Then, then infrastructure as well is another constraint. We need a very strong quantum facilities. I mean, we need very reliable internet access as well. We need research laboratories, institutional support as well. It does not mean infrastructure is not just about the quantum hardware. It includes high performance computing, cloud access, simulation tools, and all that. Do we have it as Africans? We do not have it. So then these challenges are very serious, but they are not impossible to also overcome as well, because they point us toward where investments and planning are actually needed as well. So to talk about the where investments and planning is needed, we can look at the great impacts that we could have in terms of quantum science and technology, how meaningful it will be for us as Africans, and how we could connect African problems and African development priorities in different areas. I mean, all over Africa, agriculture is very important. There are quantum optimizations that could support crop planning. In terms of energy, we could look at quantum models to enhance our grid management systems. I mean, logistics and all that. So all these areas, from agriculture to energy, transportation, health, climate, science, cyber security, they are all very important for us that we could apply quantum science and technology. So the African agenda should not just be abstract. I mean, it should be connected to the things around us, to the physical things that we keep doing each day, to the very knowledge that we are exposed to, and all that in terms of all these areas. But then to develop these applications, we first need people. People. That leads us to the talent pipeline. We need people. And how do we build the future with the people we are talking about? So the first step is quantum literacy. Student needs to be exposed, educators need to be exposed, the community at large, they need to be exposed to quantum ideas, just like what happened today, that we were first exposed to the quantum ideas. So we need to introduce this concept into our curricula. Since it's a constraint, I think it is time we have to talk about quantum literacy and other things as well. Then boot camps are also there because they are very practical. If we are doing boot camps, it's more hands-on training, it's more practical for the people. They are able to write code on their own, they are able to run simulations. Then they are also even able to learn the cloud quantum platforms that we are discussing today. Then there's a postgraduate research. Africa needs more postgraduate students. Africa needs more master students, more PhD students who are actually working in quantum science and technology so that they can co-develop, they can build as well. Then the mentorship, the mentorship. I think this forum even serves as a mentorship to students, to educators, to those who are now connecting to the field, because we need role models. We need supervisors who can actually guide us into the field. And the interdisciplinary courses also comes in as well. Once we build the people, we must then also provide tools for them that will allow them to do the meaningful work that we are talking about. So it is time to think about cloud platforms, which are already available for us to be using and be experimenting with. We have to think about high performance computing. We have to think about regional labs. I mean, in Ghana here, most people, when they want to do simulation and all that, they have to connect to the HPC in South Africa. I mean, can we have more of this HPC around so that even as we build the people, they could have access to that? Can we think about regional labs? Regional labs. I mean, one country cannot do it alone. An individual cannot do it alone as well. One institution might be difficult to do that. So not every country or not every institution or individual actually needs to build everything alone. But then these regional hubs can actually support the training, the collaboration, and the access we are talking about. And this approach will actually allow Africa to start where it is, while also building toward more advanced infrastructure over the time. However, infrastructure and talent alone cannot be built by individuals. We need a coordinated roles across sectors. And this is where the governments, the university, the industry, and our international partners come to play. We need a roadmaps, strategies for quantum development in our countries. We need our government to actually allocate funds to support our postgraduate students, to support some of these activities that we are doing, the institution as well in their budgets. Can they allocate some money, some funds that, okay, we are going to support 5 postgraduate students who will be doing physical sciences, who will be doing work in this area and all that. We need everyone on board to actually make this happen. So the key point is that no single institution can actually build Africa's quantum future alone. We need a coordinated ecosystem involving everyone that we are talking about. And with these rules in mind, then we can think about Africa's quantum development in phases. So we can then think about, in the meantime, what can we do as Africans? What's our priority? And in the middle term, so I mean, currently we are at awareness initiatives. That is what we are doing. But in the medium term, can we think about centers of excellence across Africa? Then in the long term, we could think about African-led quantum applications by its own people. The future should not only be about importing solutions. No, it should be about developing solutions that respond to our African needs. And for this to happen, we need communities where everyone can learn, can connect, and can grow. And I mean, we are happy to see very vibrant communities on the African continent who are working so hard, like the AQC, the African Quantum Consortium, Quantum Africa, then we have Keyword as well. Joining such communities is important for all of us, whether you're a student, you're an educator, a research, a policy maker. It's important because quantum computing is rapidly evolving field, and no one goes alone in this space. So these communities actually provide the mentorship, the resources, the collaboration, and the opportunities we are discussing about today. And one of the communities, I mean, that has made efforts for Africa so much is the AQC. I mean, so the AQC, it's all about building an African ecosystem that actually connects researchers, education, policymakers. I mean, that is what is actually happening today. And we have the evidence of what AQC does as well. So it is very important. We are saying that forging local strength, dividing global impact. Africa must build from local realities, local talents, local needs, whilst also contributing to the global stage as well. And to show that Africa is already gaining recognition in the global quantum, I mean, last year in the International Year of Quantum Science and Technology, Africa made strides as well. And I mean, there were people already, people in the continent who are working in education, in terms of mentorship, in terms of communication, security, and innovation. This shows that Africa is really not absent from the quantum evolution. We are already present through education and through all the things that I mentioned here. But let me say that recognition should not be the end. It should rather inspire us. It should rather motivate us. It should rather urge us to be responsible and use these quantum technologies responsibly as well. So, after seeing where we are, what we have, what we lack, and what is possible, the question then is, what must we do next? What must we do next? So my call to action then is simple. Together we can innovate solutions. Together we can innovate solutions. So for students, I encourage you to start learning today. For educators, I mean, let us introduce quantum ideas early to the younger generations. And to the universities, what they can do is actually create research pathways to support the postgraduate work. And the governments, the founders, and policymakers, let us invest in the scholarships, in the infrastructure, and the national quantum strategies that we are talking about today. So as we leave this discussion, I invite all of us to ask ourselves, what role will I play in Africa's quantum future? And what role will you also play in Africa's quantum future? Thank you.
Thank you so much, Dorcas. I know if this was a physical room, there'd be a lot of round of applause, but you can see it. You can see the round of applause emojis. I think we've learned so much from your presentation. Thank you so much for sharing your expertise and your time with us.
Thank you.
We now move on to the heart of today's forum, the Zimbabwe Quantum Story Showcase. This segment is proof behind today's theme. Each speaker has 4 minutes, or now kind of down to 2 or 3 because we need to catch up with time. So each speaker, I'll give you 3 minutes. And we're asking for personal stories, not technical presentations. The question is simple. Where did you start? What door opened? What should someone watching do next? And to all our speakers, please keep it honest and useful and clear. And I will keep very firmly to time so that everybody has an opportunity to get heard. So calling up for our first speaker, showcasing is Mikaya Nira. Mikaya will share his pathway into quantum and what early learners in Zimbabwe should understand. Mikaya, your 3 minutes starts now. You are muted, Mikaya.
Okay, thank you. Can you hear me?
Yes, we can.
Okay, all right. So my journey started on Instagram. I was someone who was always into physics and computers and science, that sort of thing. And whilst I was on Instagram, I would search for physics and science related posts and pages. So one day the algorithm just gave me a post on the Coding Schools program on quantum computing, the introduction to quantum computing, and then I quickly applied for it because I had nothing to do. This was just after O-level, and at that time I believe I was or 6, and I was waiting to go to formal schooling. I was just at home waiting for that. So I applied. My application was successful. Then I started a program, which was amazing because we were trained. These are high school students and some undergraduate students who were being trained by professionals, people from MIT, people from the University of Berkeley, training us on quantum, and it was holistic because we did the theoretical side of things, and also we touched on the practical things as well. We used IBM's quantum computers for coding, and we also learned a lot of physics there. And surprisingly, my O-level physics was enough. Zimbabwean O-level, Zimbabwean O-level physics was enough for me to do that. Even the maths was enough. The linear algebra we learned in Zimbabwe O-level was enough for me to do that program. And so yeah, that's how I got into quantum. The program was for 6 to 8 months, most of 8 months. And after that, I got a certificate, and I was really interested. I wanted now to have a career in quantum. So what I then did was I looked for quantum computing here in Zimbabwe, which led me to people like Lorraine and Farai. And here I am now. I'm not so sure where I'm at on time, but I'd say yeah, that's it. And everyone has already mentioned that. I would recommend the AQC. They've got a WhatsApp channel, very educational. Yeah, that's it. Thank you so much.
Thank you so much, Mikhail. Up next, we have Lorraine Majidi, one of the key Zimbabwe-side voices helping build this community. Lorraine, please give us the Zimbabwe community builder view, what you've seen, what is needed, and how people can join.
Thank you very much. I've already introduced myself. I'll briefly, in like 20 seconds, share my journey, what I think of that, and jump right to the question. So I'm a master's student at the University of Sherbrooke, part of the Quantum Institute and a founding member of QZimbabwe. So that's why I've done a lot of community building also with Africa Quantum Consortium as the national coordinator for Zimbabwe. And I've also worked with Under One Quantum Africa. My journey began with just saying yes, a simple message from Esther, who was my high school colleague and friend who told me about One Quantum Africa, jumped in, said yes, took up the challenge to learn. So, it's always interesting when you have connections and, it's all about saying yes. So please keep that in mind. So what I've seen so far from the community is that there's a lot of talent and there's a lot of curiosity from the universities that I've been to, from the high schools that I've been to other events that I've been to in the country. I've seen that there's a lot of interest, there's a lot of curiosity, and I appreciate that now at this juncture in Zimbabwe, we do have communities, because at some point it was just that people are curious, people have the talent, but where do they go with that? Where do they take that curiosity? But at this point, there are communities. There is Africa Quantum Consortium, there is QZimbabwe. So I would say that people should plug into these communities, take advantage of them, is something that Mikhail has already mentioned. Even the speakers prior have mentioned this. So I think that we already have that infrastructure. So I think people should jump into that. The quantum community, the quantum computing community is very warm, and everyone is continuously learning. So that helps you feel good about where you're at with your learning. And the community is always willing to help other people grow, and it is very supportive. So I would say jump in, plug in, don't watch from the sidelines, but participate. These communities are already there. Don't just be an observer, but rather participate. Your input is important. We want diversity. We want people from all the fields, from physics, from science, from mathematics. Let's all jump in and, make our community stronger. Thank you.
Thank you. Thank you, Lorraine. I want to throw in and the arts. Everybody is welcome. I am not a scientist, but I'm very much within the community, and I come from a business and creative background. So quantum is that big of a community in that it needs every player. So thank you so much, Lorraine. Up next, we have Michael Gumbo. Michael brings a hardware and engineering facing perspective. Michael, help the audience understand what it means for a Zimbabwean to see a path into the quantum technology world. And of course, share your journey.
Hi, everyone. Can you hear me or see me?
Yes.
All right. Yeah. So like in short, with the educational background, I'm not as educated as most of you guys here. I did my bachelor's degree in mechanical engineering here in Finland, but I had done like a diploma in electrical engineering in South Africa and spent quite a number of years there. My quantum journey, I got entangled, pun intended, in a with more of the quantum infrastructure isn't like most people when they think of quantum they just think of the chip, but they rarely think of the hardware which actually makes it work. So I'm more involved in the back end of how things are. So at the moment I'm working as a mechanical engineer in the R&D and engineering change management activities for a small firm, or rather big firm called Blue Force. They develop cooling systems for quantum computers. So I think there was a professor earlier on who was talking about how these qubits work. So in short, those qubits, at least the ones we are superconducting qubits, they need like super low temperatures for them to work, and we develop those refrigerators, should we say, that that make the thing work. So I started at Blue Force as a trainee about 3 years ago. Then got involved in quite a number of research projects and also like general mechanical engineering activities. What opened the door? Well, most companies, particularly I think in Europe and even in Americas, they do have these hiring cycles where they hire international, all students who are looking for an internship, for which for me it was quite mandatory that I do the internship for me to graduate. So that's how I managed to start here at my company. Then what changed? So I'm trying to stick to the script. What is the biggest lesson? The biggest lesson is that this is a new frontier in technology that I think majority of the people, even the insiders, be it whether in quantum or in cooling infrastructure or whatever, we are all learning as we go, and there is major developments like with I think one professor mentioned IBM and Google or Alphabet, and all these big companies. There are actual strides and roadmaps which are clearly showing that okay, there is something workable. The idea works, and now it's more or less about scaling and the business case for it. Like how can we get money from it, and that's how you get investors into it. If you're watching from Zimbabwe, what are the next practical steps which you can take? If I'm to use myself as a template, is that dream big, as in look for opportunities everywhere. And then when it comes to the academic side of things, STEM is the way to go. Quantum ecosystem is an integrated system, meaning that we need electrical engineers, mechanical engineers, we need scientists, we need all these kind of people to develop, co-develop rather, the whole ecosystem. So if you stick with STEM, and then you look at the right companies, as in the mostly IBM. If here in Finland, then it's mostly Blue Force and other, like is it Mabel Quantum also? Quite a number of companies that are actually developing either cooling infrastructure or developing quantum itself. And of course, if you would want to ask more questions or get in touch with me, you can find me on LinkedIn. I'll share my link there, then we can ask more. You can ask more questions if there's something, since we don't have much time to discuss here. Anyway, thank you so much.
Thank you so much, Michael. Thank you for sharing that perspective. Yeah, I think I'm starting to see a trend, but I will say it at the end of the showcase. Let's move on to Esther. Esther Munakandafa is, please can you share your journey and what opened the door for you and what Zimbabwean students or institutions should take very seriously right now? The floor is yours.
Thank you very much. Can you hear me? Am I audible?
Yes, you're very audible.
Okay, my name is Esther Mnakandafa and I'm the co-founder of QZimbabwe, and I'm also a tech entrepreneur. So my journey in quantum started back in 2020. I was following on Twitter, actually. I was following a channel called Mentorship Sim, and they happened to be a man called Farai Mashandu, and he was talking about quantum computing. And I became very fascinated. So I just decided to follow through the whole conversation. And thereafter, I got in touch with him. And what happened was actually quite surprising. So I was just hoping to form a connection. And the next thing I know, he's telling me that I want you to rally the youth and form a quantum community in Zimbabwe, which was quite nerve-wracking considering that I'm actually an introvert and I just loved being in my bubble. So I then ended up communicating with students throughout Zimbabwe, from HIT, CAT, NAST, UZ, trying to onboard them so that they join the quantum community. So that's how my journey began. And some of the challenges I faced there was answering what quantum computing was. And to help with that, I joined QWorld. I learned the fundamentals of quantum computing and programming, and it became easier. Another challenge that I faced was retaining the students that had onboarded, because the onboarding for students themselves is not hard because we are quite enthusiastic human beings. However, the retaining was quite hard because of the society we are in. People are trying to survive and trying to look for ways to make money or benefit financially in the short term. So we ended up having a few people within the community, but it was still great. And then also another challenge that I faced was also the onboarding of the professionals themselves, the lecturers. So that also taught me how to handle rejection gracefully. So it wasn't only about the success of getting people on board, I also had to learn how to handle rejection. So my message right now to the youth and to the students or any enthusiast is that you don't have to start from scratch like what some of us might have done. The community, the resources are there. It's just a matter of communicating and linking with people. The community is quite friendly and helpful, as Lorraine mentioned. I know that if I want to go to India or Nigeria, I already have a community because we built that since 2020. So no need to start, expose yourself and make sure that because the moment you expose yourself, you are then surrounded by all these opportunities. It was just through that simple message to Farai Mashandu that I found myself part of this community. And in addition, it was also a pivotal moment in my professional career because I learned to speak with almost everyone and anyone through the exposure that I got under the quantum community. So that's it from me. Thank you for the platform.
Thank you so much, Esther. Valuable lessons. And yes, it's not all smooth sailing, accepting the lows as well as the highs. It's all part of the journey, isn't it? So thank you so much for being so vulnerable and honest with that reflection. Up next, we have Edmo Chingwe. Edmo, please could you bring your perspective as an educator and a thinker and a community voice? What should Zimbabwean learners and institutions probably understand from this moment? The floor is yours.
Thank you so much. I'm happy to be here with you. I'm happy to see you, Laura, Farai, and Lorraine, and everyone else. Edmore is my name. Thank you. I think you've already mentioned that. My journey started with getting in touch with Farai. I like it because it was physical. We lived in the same space during that time, just before COVID-19. And so he shared with me what quantum was, and also interested in it. And what's interesting is that then I asked myself, I'm an educational psychologist. I asked myself, do we have something similar in psychology? And then I realized that there is something also called quantum psychology. And then that's when I started to try and understand quantum itself. And then we came together later on together with Lorraine and Rebecca, and we rewrote something that we presented last year at a symposium in Zimbabwe, just to try and present the case of quantum to Zimbabwe. And then so I come in not really as a scientist, as a mathematician, but I like research. I like the interdisciplinary approach to things. And also, I think my contribution also comes in as a psychologist in neurodivergence. I realized that quite a lot of scientists, innovators, the like of Albert Einstein, Isaac Newton, all those are neurodivergent. And so when we are taking up new technology, there is a risk of excluding the neurodivergence because we think they can't do it, they can't make it. But, and also if you look at the classical nature of technology, you know, the binary nature of technology, that it's something is either 0 or 1. There is no center, there is no middle ground. And so I've tried to interpret quantum in terms of domesticating it to Africa, making it African, finding a middle ground in Africa. So you understand that quantum, the qubits, they exist in superposition. They can either be 0 or 1 simultaneously at the same time. And we have that in Africa. You see, you are an individual, at the same time you are a committee member. So you have your own identity as an individual, but you still have a community identity. And so I've tried to understand and see how we can domesticate quantum in Africa and make it understandable to Africa and make it accommodate the middle ground, you know, our indigenous knowledge systems, how we can find ground in quantum. And I believe quantum has the potential, you know, to find our context and to operate in a way that solves our problems in a contextual manner. And so I think what we need to do going forward is to continue the conversations, try to work on our curriculums as an educator. I believe curriculum is key also to try and innovate through curriculum, starting like I like your perspective on how we should start from the ground, from the grassroots, because it's nothing difficult. It's not as difficult because we already have these concepts in our African philosophy. You know, people will always exist together as an entanglement. You can't do it alone. You see, you can't do it alone. And so we can use these concepts to try and understand quantum, and therefore then develop solutions to solve the problems that we have now. So I think that's all. Thank you.
Thank you so much, Edmore. I love that as a Ubuntu researcher, like finding the parallels between quantum and how we exist as communities, for me is beautiful. And I think in the very first happy hour, or the second happy hour, I joined for the AQC, which is tonight, by the way. I'm just going to shamelessly plug in our happy hour happening later this evening on a Friday evening. We'll share the link in the chat. But I actually said quantum. After hearing a few times people talk about it, I said quantum sounds like the autism of science. It sounds like it is the autistic member of the science community because it exists on a spectrum. It is neither here nor there. Quantum in and of itself is a spectrum of existence. So there's no one such problem. It's how you look at the problem, how you evaluate the problem that then defines the problem. So I quite like your perspective. So I hope that also continues to reinforce what we're saying in that quantum actually even does go beyond it does go beyond the scientists and the physicists and the technical, but there's also another layer to it that makes it tangible. And I think your work speaks towards quantum literacy. So thank you so much, Edmore. Finally, but certainly not least, we have Kudzai Musaradenga. Kudzai, please could you share your pathway and what helped you move forward? What practical lessons others might be able to take from your journey? The floor is yours. Kudzai, can you hear me clearly?
Yeah, there we go.
There you are.
I didn't have mic permissions.
Oh,
Can you hear me well
sorry
now?
about that.
Yeah, no,
Yes,
that's
we can
fine.
hear you.
Yeah, absolutely. Yeah, thank you, and lovely to see you again, Aura. So my journey in quantum, I guess the more official one, started about some 3 or 4 years ago. I was working as a physics student at my university, and my professor convinced me to quit my job so I could join his lab, and that's how I started working on quantum hardware. And more recently, that has involved to like quantum algorithms and things like that. But that's how I got started. And maybe please repeat your second question again. I was trying to work on my mic.
Oh, it's essentially what could people learn from your own journey?
Yeah, I think I'd say this is one thing I've really learned from being part of AQC. It's a sense of agency. So, when I started, I was working as an undergrad researcher. Most of what you do in that, space is just being told what to do and following instructions and making sure that things are repeatable and explainable. And in joining AQC formally last year, I think before that I used to be more of like a quiet member. I would tell everyone about it, but I didn't actually show up to meetings and things like that. I've been able to take more agency. So, for example, when I interact with new materials, I'm asking myself more, what I can do to advance what's being done by other people. I don't feel the sense of needing to get permission from people to get to work on stuff. And so that's just what I would maybe advise other people. When you interact with learning material, ask yourself what you can do to contribute and advance what you're reading and learning further in whatever capacity that you can. But yeah.
Beautiful. Thank you so much, Kudzai. And yeah, wishing you all the best in your journey. Are you maybe for I think you didn't mention where you are now and what you're doing right now, in case people are curious.
Yeah, absolutely. So I'm working as a research fellow. We do quantum algorithms, but combine them with HPC. So it's high performance computing and quantum computing combined together. We do solutions for PDEs, things like that. But outside of that, I have been working for about 8 months now on a project to try to automate like device tuning in quantum computers. So most people do not know this, but before like a quantum computer actually computes, someone has to like manually tune it and put it in a state where it can actually do the job. That to me sounds so ridiculous. So I'm trying to solve that problem. But yeah, that's what I'm working on now.
Fantastic. Thank you so much for sharing that. And thank you for closing out our showcase session. So we are going to go into a lightning panel. I'm glad because my panelists are used to pressure. So we're gonna have a lightning panel. And I'm really excited to unpack what do you really want to get down to? Because we've got a short amount of time. So our title is Getting Started in Quantum: Students, Clubs, Universities, and Government. I want this panel to be practical. So short answers. Let's try not to over theorize. And I know it's really hard because we've got people who are very used to talking. So please try and keep it short. We also just want to understand, we need to leave knowing what to do this week. So now I've sat in this forum, now what? What to do in the next 90 days and what institutions should actually take seriously. Like, we need to leave with, you are our pressure point. You need to now give us our next steps. This is what needs to come out of this panel. So I'm going to probably kick off in one sentence. Okay, so it's opening round. So each of you have a couple seconds to respond to this. In one sentence, what is the first serious step someone in Zimbabwe should take today in quantum? Sarah, we'll go ladies first, and then carry on from there.
Okay, so hello everyone. Thank you for your efforts, and I'm happy for being here. The first serious step is to create, for someone who attended this forum, it's to create a small structured entry point for quantum, such as starting in organizing seminar series, online events, create like student group or a club which can be connected to an international network. So by then the learning and the collaboration can be starting right now.
Awesome. Mohamed? I think you're muted. I think they need mic permissions. Farai, are you able to assist? There we go.
Yes.
Okay, we can hear you now.
Oh, okay. I think the first thing to do about quantum is
you could suppress your video, Mohammed, is because you're coming in.
The first thing to do about is to
all right. I think that network is not happening. Yeah, as he fixed that, let's move on.
Okay. So what? Okay. So we okay. Let me adjust. Let me adjust in real
maybe
time.
I can come in
yes,
on that one as well.
Please come in.
While that is happening. So yes, thank you so much, and I'm super humbled that we are able to do this. So what do you need to do in order to get into this ecosystem is stay close, right? We shared a lot of resources and ideas. It's not like we are the only community and platform where things can happen. There is a lot, and everybody is welcome into the room, right? I think that's one very important thing that I want to mention. We focused on STEM. We talked about people who are in maths, physics, and you name it. But there's a space for everyone. Quantum computers are being marketed. Quantum computers are being humanized by people who can communicate. We need creatives. We need journalists. Because these are stories that have to be told out there. They are narratives that have to be, shaped out there. And it is time for everyone to bring hands on deck and collaborate and just come into the ecosystem. You may not really want to understand how a quantum computer works because that is being abstracted every day. So at the end of the day, we are also going to get to a point where we are with the, your ChatGPTs and just the way we use computers today. You don't have to know that there's silicon under the hood. So that is the same thing that is going to happen to quantum. So we need everybody at every level. It could be teachers finding their own ways of introducing quantum in their curriculum. What, for example, Edmo didn't mention is Edmo is a history teacher. I met him at Plumtree High School and we were talking I am a physicist, he's a history teacher, but I also love history. History has got a role to play in understanding even the uptake of technology, in handling change, and just helping people think through and process change, which is a constant part of life. So I'm saying here, forget about the qubits that we talked about. Think about technology as a tool, and then say to yourself, why is it important for me to understand the tools that are around me in order to achieve my goals and to do what I need to do? And then if you are having challenges with that, then stay close in the community, because you're going to meet people like you or who may be thinking in the same direction. And before you know it, things begin to happen, opportunities unfold, and you begin to flesh out this unique direction that is worth pursuing for you as an individual, depending on where you are and what you want to achieve at the end of the day. So yeah, over with me.
Thank you. Sarah, I have a difficult question for you. For a lecturer or a student group or a serious university, like what does the commitment look like at the beginning stage, and what should the first few days look like? They're sitting in the room right now and they're like, okay, we've heard you. What now? What does it look like to be serious?
Okay, so the first days should focus firstly on building structure, community, and long-term vision. So this can begin with launching a student quantum club or a campus initiative that creates a space for learning, collaboration, and discussion. So during this period, the group can organize introduction events for quantum mechanics and quantum computing. So it will be quantum awareness sessions to make the field more accessible to students from different backgrounds, maths, physics, data science, etc. So they can also invite guests from the global or from the continent also. Researchers from everywhere, like we can easily contact them by LinkedIn, and also it's also like to build a good foundation by creating a strong collaboration between the communities in Africa. So the collaboration needs to be united. So everyone needs to share the ideas, to share the news, to be updated with the news in Africa, and like this, we can go ahead with this work. Yeah. So it's about creating a strong foundation and like a strong ecosystem for the future growth.
Fantastic. Thank you so much for sharing that. Muhemeyan, are you back with us?
Yes, I'm back. Can you hear me?
Yes, now we can hear you.
I'm sorry before just Teams completely crashed on its own, and I was out of the event, but the mic was still open. I'm really sorry for that. About your question, I think Sarah said most of what's interesting here. You should, for people who want to get into the field, you should start identifying some relevant coursework that is there, that is available online through, you can either do it through AQC. We have our own initiatives. As part of AQC, there are initiatives to educate people about the field, to take them from basic knowledge to an actual practitioner. The local chapters of QWorld also do that, and the most research groups within all African countries are very actively involved in sharing materials, educating, as we are doing also in Nigeria. We have African Quantum Consortium, African Quantum Champions program to have to coordinate with local students to create clubs in their schools. So the most important part in this field is the access to the network, not for opportunities specifically, but for knowledge. If you have, and the field is the best example of that, because most communities are there on Discord. You could just hop on a Discord server and talk to someone who is the expert on a field, and that's something that most fields don't have it. So you would just need to start find the right entry points, and that's what we're trying to provide with AQC, the right entry points for people who don't know anything. Just hop on a server, identify who are the people who are working on your subject or your field of interest, and just talk to them. Everyone is very happy to share what they want. Everyone is really excited to tell you about what they're doing, to explain it to you, because we have recognized that in this field, the bottleneck of this field is not money, it's not the technology, it's the human resources right now. And everyone wants more people involved in their field. Everyone wants you to get involved. Everyone wants you to get excited as much as they are about their research. So just find the trustful place to start, such as AQC or Q or the chapters, and just follow it. You just keep on asking questions. There are no stupid questions in the field, because the field is just weird and counterintuitive. No one knows what's going to happen. We all are discovering it. So you can just ask any questions. Don't feel afraid. Just keep going. Just feed your curiosity. Just do that. Like, be curious, and no one will judge you. No one will stop you. Everyone will be very excited to listen to your questions, not even to answer them, just to listen to them. I personally love it when I get last year we had some high school students who were interested in quantum, and they just heard about our event, so they googled some quantum and Bell experiments and CHSH inequality, and they came and they were really excited with the questions, and what does this mean? What does this mean? And I was just really happy to see them asking those questions, even if I don't provide them with a good answer, or if maybe there is no good answer out there, but just to see them asking those questions made me really happy. And that's what I ask of everyone who's interested in getting in the field. Just keep asking questions.
What a fantastic way to close out the panel. What a fantastic way to close out the panel. Oh my goodness. There's no need to add more words to that. All I will take is what you've said: be curious. And feed your curiosity. My goodness. We're looking forward to your TED talk, Mohamed. When's your TED talk coming, so that you can, if you need a motivational speaker, he's here for you.
Soon, hopefully soon.
Thank you so much to our panelists for such a great lightning panel. I think a good first step as well, while I bring on Farai after this, please, could we all start sharing our LinkedIn profiles in the chat? Connect, because it's one thing to wait for the recording, it's one thing to be in the room, but it's another thing to actually connect with people. So please, if our speakers, panelists don't mind sharing their LinkedIn links, their profile links, and please, for the students, if you don't have a LinkedIn profile, please create one in the next 3 seconds while Farai is speaking, and let's connect and start to actually plug into the community, because as Mohamed said, we want to talk to you. So Farai,
okay.
We are now closing. What now? What happens next? We've had this awesome forum. What's next?
Thank you, Aura. Let me be direct. Today is the proof point, right? We showed that this has been happening. There are people from Zimbabwe. Some are still based in Zimbabwe. Some were based in Zimbabwe and they left Zimbabwe. And they come from different fields. Lorraine from ICT at Chinhoyi University of Technology. And we had people from high school students. We had people in different spaces talking about quantum, and this has been happening for a while. And there's a lot more now. There's a community. There's somewhere to plug in. So Zimbabwean people in the field, Africa as builders. The next step is to turn these individual stories into a pipeline. And if you're a student, join the community and start learning with others. We have got resources for you. Believe you me. We have so much of a good presence across Africa and so much of a connection across the networks to its history that we know how to help you, everybody. If you're a lecturer, we also know how to help you integrate, because we have been there, we've been students, we have taught, we have introduced these programs. We have programs with the top companies and the top providers of content across the world, and we can help you get started. We've got a Quantum Champions program. Get on it, start a club, send us your requests. We will walk through this with you. We don't expect you to come in knowing anything or everything. If you want, we'll take you from where you are and we'll take you to where you need to go. We've built an infrastructure for you, take advantage of it. If you're an institution, we want to talk. So we think strategy. We are building the future leadership of Africa. We are not talking only about quantum. We are setting up Africa for progress, for development, for growth, for solving those problems in your backyard. We need more efficient solar panels. That's quantum. We need more computing power. That's quantum. We need to eradicate diseases across the continent, drug discovery. That's quantum and chemistry, and you name it. We need to optimize our networks, our grid, our connections. We need to deal with water, sense it, process it, manage it, you name it. That's all quantum. So there's a lot of quantum that we didn't talk about. We talked about the computing, but there's a communication, there's implications in cybersecurity. There's a sensing part of it, discovering resources on the continent, more efficient ways of detecting minerals, you name it. So there are many other things that are strategic and high level that you can get from this community. And we talk about these things in our newsletter and in our different forums. And please stay in touch. And there's a civic space as well, because, we handle all these conversations to shape the narrative. What should we be talking about in Africa? We should be owning our story. We should be building ourselves. We should be, training our people and taking them from kindergarten upstream. We have a plan around that, and we are happy to talk to you about some of the ideas we have. So if you're in the diaspora as well, we are connecting these guys in the diaspora. You saw them, they work for the top companies, and there are other people, many that couldn't join today from Zimbabwe, and representing this country and representing the continent and willing to engage and help you see a way forward. We will share a recording as a follow-up when we process it. We will hope to have you stay around. We've got another beautiful event coming, which we're going to be promoting as well. So we see you in 2 weeks' time. We'll see you for the roundtable that we do on June 26th. We will see you on a happy hour today later on if you are up for it, where you can ask questions and even challenge us and talk to us about anything. We talk strategy there. We have fun. We have drinks. We hang out. We close the week and we get into the weekend. Thank you so much for attending. Thank you, Zol. Thank you, QZimbabwe. Thank you to all the leadership, Esther, for believing in that simple moment. It got us today. Super proud of you and all you're working on and the community that we now have in place. Thank you for everyone who made this attendance possible and who reached out broadly to get people into the room. Thank you, Ora, for your time. All the people that you met today are really awesome people who have got busy lives, who gave up their time to be with us today, and I want to thank you. Back to you, Ora.
All right, thank you so much. You've done my job for me. You've done our vote of thanks. As you've heard, please check the chat for all the links to our AQC channels. But if in doubt, just look for the Africa Quantum Consortium everywhere where you're on social media, and you will find us if you haven't found what you're looking for in the chat. So today's line was, since 2020, Zimbabwe has been building, and here is the proof. The proof is in the pudding, and I hope you enjoyed today's serving of pudding that we served you. And now the work is to keep building. Thank you so much to everyone, and we hope to see you in the community channels. And until next time, bye for now.
Thank you, thank you, thank you so much.
Thank you, everyone. Thank you.